All right, today we're doing properties of logarithms. So our essential question is, how do the properties of logs relate to our rules for exponents? So it's very important that you know these rules. We have 3 rules and they come based upon our rules of exponents. When we had exponents, if you had a base, when you had a base value to the m times the base value to the n, if they had the same base, you could add their exponents. So the logarithm product rule is similar. If you have multiplication inside your logarithm, then you add the separate bases. So it's undoing. So when you had the bases, separate bases multiplied, you added within a single for an exponential. For a logarithm, undoing it, when you have multiplication inside the log, you have addition of separate bases. And so in our rules of exponents, if I had division, then I subtracted the exponents. So similar with logarithms, when I have division inside a logarithm, I subtract the separate logarithms. And our power of a power rule, this one looks a little different than what you're used to, but it was, if I had b to the m times n, you would have multiplied it. And so you do have multiplication of that power in front of your logarithm. So you do multiply that power in front of your logarithm. So all 3 of them come from undoing, being the inverses of your exponentials. So these are 3 rules you need to know. Multiplication inside a logarithm is addition of 2 logarithms. Division inside a logarithm is subtraction of 2 logarithms. Notice you're subtracting the denominator. And a power inside of a logarithm comes in front as multiplication. Okay, so using the product rule. If I have log base 4 of 7 times 5, we're going to expand it. Expanding it means we want to get it out into more logarithms. We're going to get rid of that multiplication side. So I apply the base to the 7. And since it's multiplication, it becomes addition. So logarithm base 4 of 5. And that's my expanded form. When I have 10x, that's really 10 times x. Now notice there's no number on the base here. If there is no base listed, then that's base 10. So our base of our number system. If you don't see it labeled, it's base 10. And so I'm going to take 10 and x are being multiplied, so I'm going to expand them as addition. So I get log of 10 plus log of x. Now, what's really important to note is if the base isn't labeled, is since it's base 10 and I have an input of 10, remember that the log, if it has the same base as its input, they cancel each other out to be 1. So they simplify to be 1. So I get 1 plus log x. All right, so I'll go ahead and hit pause. Try the bottom 2. And when you're done, hit play to check your answers. All right, so you should be hitting play now to check your answers. So, oops, I skipped ahead on accident. Let me fix that. All right. Okay, so I have log base 6 of 7 plus the log base 6 of 11. I have log of 100 plus log of x. Now 100's not 10, but 100 is 10 squared. So since it's 10 squared, log and 10 are inverse, they cancel each other. So I end up with 2 plus log x. 2 plus log x. All right, the quotient rule. Now we'll do the same thing with the quotient rule. So division inside becomes subtraction of separate logs. So I get log base 7 of 19 minus log base 7 of x. And that's it. All right, nothing I can do because 19 can't be written in terms of 7. On B, remember that ln is log base e. Remember, ln is log base e. So it's natural log. So this becomes ln of e cubed minus ln of 7. So it's always the top minus the bottom. Now, since natural log and e are inverse operations, they cancel, leaving you with a 3 minus ln of 7. So go ahead and hit pause, try the next two, and hit play when you're ready to check your answers. Okay, so you should be hitting play now to be checking your answers. So I get log 8 of 23 minus log base 8 of x. So notice the base of the log does not change. On B, I get ln of e to the 5th minus ln of 11. Natural log and e are inverses, so they cancel, leaving me with the exponent. So 5 minus ln of 11. All right. Power rule. So when there's a power, I bring it down to the front. So if I look at this first one, it's pretty straightforward. I just bring that 4 to the front. So I get 4 times log base 5 of 7. That can't simplify because 7 can't be rewritten in terms of 5 as a base. Now, when I have natural log of square root of x, I need to rewrite x as a fractional exponent. So remember that a square root can be rewritten as a fraction with your index of the root in your denominator. And since it's a square root, the index is 2. So then I just bring that 1/2 in front. So I get 1/2 ln of x. All right, so if I look at C, I'm going to start by bringing down the 5. So I get 5 logarithm of 4x. But now that I've gotten rid of the exponent, I see that there is multiplication. So multiplication can expand into addition. And so that 5 is going to stick with each of them. So it's 5 log 4 plus 5 log x. Because that 5 was being applied to both of them. And I could also just write the 5 in front with parentheses. So go ahead and hit pause, try checkpoint 3. And when you're ready to check your answers, hit play. All right, so you're hitting play to check your answers. So I bring the 9 in front, and I have log base 6 of 3. Now, can 3 be rewritten in terms of 6? Not in terms of powers, because it's not the square root of 6, and it's not 6 to a power. So we're done. That's our answer. On this one, I rewrite that radical as a fractional exponent, but this time it's a 1/3 because the index of the radical was 3. So I get 1/3 natural log of x. All right, I bring the 2 in front, and I get log, and I need to keep that parentheses. When there's addition and subtraction, it's important to keep parentheses, showing that the logarithm applies to all of that. Now, this one cannot expand. There is no rule for addition inside the logarithm. Since there is no rule for addition inside the logarithm, I'm done. It's when there's multiplication inside, it can expand to be 2 separate logs. But logarithm can't distribute across or anything because it's a function itself. So it can't distribute because it's not an actual term to distribute. So that's it. You're done. Nothing more you can do on that one. So now we're just going to apply multiple properties to expand as much as possible. So I'm going to divide my paper into half, and I'm going to do A on the left side over here, and I'm going to do B on the right side. All right, so let's see. The first thing I see is multiplication. So first thing I'm going to do is get rid of that multiplication. So I get log base B of x squared plus log base B of the square root of y. But that x has an exponent, so I'm going to bring that in front. So I get 2 log base B of x plus Well, I know the square root can be rewritten as an exponent, so I'm going to rewrite that as 1/2. So now that that's an exponent, I can bring it in front. So I get 2 log base b of x plus 1/2 log base b of y. All right, so on the next one, first thing I notice is this division. So I'm going to get rid of that division. So I have log base 6 this time of the cubed root of x minus log base 6 of 36y to the 4th. Well, over here, I'm going to rewrite that one. I've been forgetting my equal signs. I'm going to rewrite this one as log base 6 x to the 1/3. And on this one, I'm going to get minus, and I have to do parentheses because it's going to be applied to both of them. Since there's multiplication, that's log base 6 of 36 plus log base 6 of y to the 4th. So it applies to both of them, which means that negative is going to end up distributing. You could have actually skipped to that. If you notice, when there's multiple things in the denominator, you could just subtract each part individually as well. So follow your comfort level with combining rules. All right, so on this one, I'm going to bring the 1/3 in front. So I get 1/3 log base 6 of x minus log base 6, but 36 is really 6 squared. And I distribute the negative, so it's negative, and I bring down the 4 log base 6 of y. Log base 6 of y. So almost done. 1/3 log base 6 of x. Log 6 and 6 cancel, so I get minus 2 there. Minus 4 log base 6 of y. And so that's about as expanded as I can go. Go ahead and hit pause, try the next checkpoint, and when you're ready to check your answer, hit play. All right, so you should be hitting play to check your answers. So I'm going to break apart the multiplication using addition. The 4 comes in front. And that cubed root is really a 1/3, so I'm going to bring the 1/3 in front. So on the previous ones, I wrote that as a separate step, but feel free to just go ahead and apply it as bringing it down in front of the logarithm. All right, on B, since I see division, I'm going to subtract. Okay, and then for log square root of, oh, I forgot my base. My base on this one was 5. So let me go right in that 5. The base is important. All right, so on that first term, it's square root of x, so that's a 1/2. And then on this one, I have multiplication, so I'm going to break it apart. So I get log base 5 of 25 plus log base 5 of y cubed. All right, and then I get 1/2 log base 5 of x minus log base 5. Instead of 25, I'm going to write that as 5 squared plus, and I'm going to bring down the 3 log base 5 of y. Oh, wait, that's not plus. It's not plus because I had to distribute the negative. So remember, you have to distribute that negative to both of those, which makes sense because y cubed was in the denominator, so it ends up negative. All right, so one last step to simplify. I get 1/2 log base 5 of x minus 2 minus 3 log base 5 of y. All right, and so for condensing, you just go in the reverse direction. If you see addition of 2 logs, you multiply inside. If you see subtraction of 2 logs, you divide inside. And if you see something multiplied in front, you bring it up. So they want us to write as a single logarithm. Now, something important is that they have to have the same base. If they don't have the same base, the logs can't be combined. But right here, we have 2 of base 4. So I'm going to combine, since it's addition, I'm going to multiply them on the inside. And then 2 times 32 is 64. But 64, let's see, 4 times 4 is 16. 16 times 4 is 64. So 64 is really 4 cubed. So this is really log base 4 of 4 cubed. So those cancel, and I'm left with 3. All right, over here, I have subtraction. So I'm going to combine it into a single one using division on the inside. So the first one comes on top, and the one behind the subtraction goes in the denominator. So go ahead and hit pause, try the next 2, and when you're done, hit play to check your answers. All right, so let's check our answers. I have a log of 25 times 4. So that's log of 100. But remember, log without a base is base 10. And so if I have a log of 100, that's really 10 squared. That's really log of 10 squared. So log and 10 cancel, and I'm left with 2. All right, on B here, I have log of no base again, so base 10. So I put 7x plus 6 on top, and x goes in the denominator. Those are the same exact problems. All right, so condensing is a single logarithm with multiple steps. So there's going to be 3, so I'll be sure I label each step and do a different color for them. So let's start with A. The first thing I have to do is get rid of any value in front. So I get rid of those values in front by bringing it inside as an exponent. So in this, like on this one, the x minus 1, that whole thing is to the 4th power. Now that I have addition, now I can rewrite that as multiplication inside. Instead of x to the 1/2, I'm going to write that as square root of x. And then I have x minus 1 to the 4th. And now I am condensed to a single logarithm. All right, on B, I'm going to bring that exponent up first. So I get ln of x plus 7 cubed minus ln of x. And then subtraction becomes division on the inside. So I get x plus 7 cubed divided by x. All right, and on C, now I have 3 of them. So I first get rid of that multiplication in front by making it an exponent on each of them. And then subtraction goes in the denominator of a logarithm, and anything positive goes on top. So x to the 4th is positive, so it goes on top. Both of these subtractions mean division, so they go down here. And the only other change I could make on this one is I could simplify 6 squared to be 36, and I can rewrite y to the 1/2 as the square root of y. Okay, so go ahead and hit pause, try the next set of problems, and hit play when you're ready to check your answers. All right, so you should be hitting play to check your answers. I get ln of x squared plus ln of x plus 5 to the 1/3. And that becomes ln of x squared times the cubed root of x plus 5. On B, I get rid of that multiplication in front first by making it the exponent. And then subtraction becomes division on the inside. All right, on C, I get log base B of x to the 1/4 minus log base B of 5 squared minus log base B of y to the 10th. So your final answer should have looked like the 4th root of x over 25 times y to the 10th. All right, there is a change of base property. Change of base, the main reason we need this is your calculators do base 10 and base e only. Okay, the calculators don't do logarithms of other bases, right? Even the higher tech graphing calculators all do it base 10 or base e. Base 10 is our number system and base e is our natural logarithm. And since most patterns can fall into one of those two, we use change of base to get anything into that form to do the computation. The reason that there are other bases is, for example, even though our number system's base 10, computers are a base 2 most of the time. In terms of binary is base 2. But a lot of computer algorithms are actually base 16. So different bases are used in different applications, but computationally, most calculators only offer the functionality of base 10 and E. So the way you change a base is always by doing logarithm of the function itself divided by logarithm of the base. Okay, so the first one's a generic one, but that doesn't have a ton of application. You can use it. But these two down here are the two that you use to actually do computation with a calculator. So if I have logarithm of base times m, then I can change it to log base 10 of m over log base 10 of whatever the original base was. So you always end up dividing by logarithm of what the original base was. So same thing with natural log. It's the same concept. It's natural log of the input divided by natural log of what the original base was. So you just always divide out what the original base was. So if I want to evaluate log base 5 of 140, I can't type that in a calculator. So I'm going to change it to a different base. So I can either use log or ln. And then that functions in any calculator you use. So I'm just going to use base 10 for now. So I'm going to do log of 140. So it's always a log at the top divided by logarithm of what the original base was. And now I'm going to go type this in my calculator. So I'm grabbing my calculator right now. And I'm selecting the logarithm function. By the way, I should say most calculators don't do logs of other bases, but there are a few of the really expensive ones that can, but most won't do it. All right, and so it's approximately 3.070. There we go. So go ahead and try the next one using your calculator and then hit play to check your answers. Okay, and so you should have gotten 4.022. All right, and so that's it for today.